It's the middle of the night. The pager goes off, you see the alert, production is down, hard. And after a few frantic minutes, that cold, sinking feeling hits you. You're the reason. Look, every systems engineer has had this nightmare, but for some, it becomes a reality. So let's dive into one of the most infamous production outages out there and see what it can teach us about building systems that can actually survive the real world.
I mean, this quote from a developer on Reddit just says it all, doesn't it? It perfectly captures that stomach-dropping, blood-runs-cold moment. It's that feeling when a simple command goes catastrophically wrong. And it's a universal fear in our industry because the stakes are just so incredibly high.
So let's just imagine it. You've hit enter, the command is run, the primary database is gone. What's the plan? Seriously, what happens next? Do your backups even work? Have you ever actually tried to restore one? Let's stop talking hypotheticals and look at a team that had to answer these questions for real, under the worst pressure imaginable.
Yeah, we're talking about the GitLab database outage from January 31st, 2017. If you've been in ops or SRE for any length of time, you've probably heard of this one. It has become required reading because it is a masterclass in how a bunch of small, seemingly unrelated problems can line up perfectly to create a total disaster. So here's how it all went down. It starts with high database load early in the day. Probably some spammers doing their thing. This makes the replicate database start to fall behind. By 11 p.m., replication just breaks entirely. So an engineer jumps on to fix it. The plan is to wipe the secondary and resync it. But in a moment of confusion, working late at night, they run the delete command on the wrong server. They run it on the primary. And just like that, 300 gigabytes of live production data, poof, gone.
Now that rm-rf command, that was just the spark. It wasn't the real problem. The real problem, the thing that turned a recoverable human error into an 18-hour outage with permanent data loss, was that every single one of their safety nets had already failed without them knowing.
And this, right here, is the part of the story that should keep every single engineer awake at night. GitLab thought they had a solid, multi-layered backup strategy, but when they needed it most, they learned the hard way that an untested backup is not a backup at all. It's just a hope. I mean, look at this list. On paper, it looks pretty good, right? You've got your daily dumps, disk snapshots, a hot standby for quick failover, multiple lines of defense. You'd feel pretty safe with this setup. But as the team started scrambling, they discovered that one by one, every single one of these was about to fail. First up, the daily database dumps to S3. They check the bucket, and it's empty. Why? Well, it turns out the backup script was using an old version of the PG_dump utility that wasn't compatible with their newer database version, so the job was failing every single night, but no one knew.
And here's where it gets even more painful. The backup script was trying to tell them. It was sending failure notifications, but those emails were being silently rejected by their own mail server because of a security misconfiguration. Their monitoring system was basically screaming into the void.
Okay, so what about the other options? Azure Disk Snapshots? Nope, they were never actually enabled for the database servers. The hot standby replica? Well, that was the server the engineer was trying to fix in the first place, so it was already empty, waiting for the data that was just deleted. Every door was locked. And let this be a crucial lesson for everyone. Replication is not a backup. It's for high availability, and it will happily replicate a delete command just as fast as anything else. And this is just a classic textbook violation of the most fundamental rule in data protection, the 3-2-1 principle. You need 3 copies of your data on 2 different kinds of media with at least one of those copies off-site. It's the industry standard for a reason, and in that moment of crisis, GitLab effectively had 0.
So, with all the primary, automated, easy-to-use backup systems completely useless, the team was left with one last desperate option. And the recovery, well, it was going to be painful, manual, and incredibly slow.
Their only hope was an LVM snapshot that had been taken 6 hours earlier. And it wasn't even for production backup purposes, it was just to populate their staging environment. Worse, this snapshot lived on a staging server that was using slow, cheap network storage to save a few bucks. They had the data, but getting it back into production was going to be a huge problem.
18 hours. That's how long it took to copy 300 gigabytes of data back. 18 hours of their entire service being offline for the world, all because their last resort backup was sitting on slow, non-production infrastructure.
And because that last backup was 6 hours old, the data loss was permanent. About 5,000 projects that were created in that 6-hour window between the snapshot and the deletion, they were just gone. forever. And it wasn't just projects. Thousands of comments, issues, and around 700 new user accounts were completely wiped out. You see, this wasn't the cost of one person's mistake. This was the real-world cost of a whole series of systemic failures.
The GitLab story is painful to listen to, for sure, but its real value is in the lessons it teaches all of us. It forces you to shift your whole mindset away from trying to prevent failure, which is impossible, to building systems that can survive it.
This right here is the core idea of cyber resilience. You have to work from the assumption that failures will happen. People are going to make mistakes. Hardware is going to die. A deploy will go bad. The real question is, how quickly and how reliably can you recover? The true strength of your system is defined by its recovery process, not its uptime streak.
So how do we actually build for this? Okay, here's the checklist. First, immutable backups are absolutely non-negotiable. Use things like S3 object lock or versioning. Make it architecturally impossible for one mistake to delete your only way out. Second, automate your backups, but monitor the outcome. Don't just check for a success code. Verify the backup is a reasonable size. Alert on anomalies. Third, and this is the big one, a backup is a complete unknown until you have successfully restored from it. Period. You have to automate your restore tests. And finally, run full-scale disaster recovery drills, what we call game days. Deliberately break something in a controlled way and test your people, your playbooks, and your tech.
You know, GitLab themselves said it best in their own post-mortem analysis. The goal isn't to create a perfect environment where nobody can possibly make a mistake. The goal is to build a resilient one where a mistake doesn't cascade into a catastrophe. That's a huge shift in thinking.
And that leaves us with the ultimate mental model to take away from all this. When an outage happens, the first instinct is always to find the person who ran the command and blame them. But experienced engineers know that's a waste of time. The real failure wasn't the person. It was the system that allowed a single human error to cause permanent, catastrophic data loss. So the lesson isn't be more careful. The lesson is build better, safer systems.